I really liked what Juan said about data having gravity, and I would say that geospatial data is one of the most dense data sets that we have. And geospatial data is not only large, but it's very important and powers a lot of really important workflows such as precision agriculture, emergency response, and other use cases. And kind of with it being so important and being so large, I think it's a perfect use case for compute over data. So I am John Solly, and I work for the Easier Data Initiative, a collaboration between the Filecoin Foundation for the Decentralized Web and the University of Maryland. Our team is headed by Dr. Oshan, and I am the lead developer along with Jung, and we have 2 junior developers with us. Today I'd like to talk about satellite imagery, the size and scale, and really what we're dealing with, the example use cases that I alluded to earlier, and some of the work I've done along with the people on my team to take scripts and workflows that university professors at University of Maryland and other researchers have done, things that are running on their local machines, and making these workflows more decentralized and more scalable. And when we make things more decentralized and more scalable and using decentralized technologies, they can become more replicable and more reproducible for open science. And finally, I'd like to talk a bit about the possibility of a data DAO and a university consortium. Could we all work together to collaboratively pay for compute and collaboratively pay for storage? Landsat data is an Earth imaging satellite that goes around the Earth. I will show a quick animation. So there's a satellite. There's actually many satellites going around the Earth in a polar orbit. Landsat 9 is one of them. It takes pictures as it goes around the Earth. To put this in perspective, each image is about 180 by 180 kilometers, with each pixel being about 30 by 30 meters. And we've taken 1 year of Landsat data and put that on Filecoin and IPFS. That turns out to be about 300 terabytes of data. And let's see. Yeah, so each of these images that you see on the screen is about 1 to 2 gigabytes. So you could imagine just a huge data set with 1 year being 300 terabytes. And when we're just talking about Landsat, that's 300 terabytes for a whole year, but imagine satellites that have even better spatial resolution, like the ones that can read license plates. We're talking about dozens of satellites, hundreds of petabytes of data, and that data is really heavy. Having to move around petabytes and petabytes of data is impossible or extremely expensive. Our initiative isn't just looking at Landsat. We're also exploring other satellite systems such as JEDI, which is a LiDAR-based laser system. JEDI is really good at measuring things like canopy height for measuring deforestation. And there's also a satellite system called Sentinel. And when you combine Sentinel and Landsat together, those 2 data sets allow you to have much better temporal resolution, where a single location could get a new image every 2 to 3 days, which is really useful for a lot of use cases. And yeah, just like I mentioned, with all of these different satellite systems, with all of this different geospatial data, we want to make geospatial workflows more decentralized and not as centralized. I'll now go through a few different examples of how satellite imagery, like why it's useful and why we work with it. When the earthquake happened in Turkey recently, satellite imagery was pivotal for helping the people that are on the ground. Here you can see this is imagery provided by Maxar, and the devastation can be quickly seen just at a glance between what it was before the earthquake and what it was after. And satellite imagery is a way for anyone in the world can go through this imagery and mark down, like, this is a destroyed building, and really give a lot of intelligence to the people that are on the ground to help coordinate the response. Where should we look for people that are buried under the rubble? Where should we open up first aid centers? Another use case, and this is a very classic remote sensing use case, is looking at crops and vegetation type. Depending on how the plants react to the sensor and reflect light, you can actually identify different crops. In this case, we're looking at every color represents a different type of vegetation. We're working with a Ukrainian professor at University of Maryland looking at crop yield in Ukraine and how the conflict there has affected crop yield. What I'll show next is just kind of an example of how we've taken workflows that are very centralized, very tied to one workstation, and how can we find ways of making them more decentralized. Let's check this out. I had it right here. Okay, so here is a Jupyter notebook that I wrote of your running. You have to do all these Python library installs, and the reason I'm mentioning this is kind of how inhibitive this is to doing research. Of if anyone wanted to replicate my analysis just using this notebook, they would have to install these libraries. We also install IPFS and use the Kubo CLI. But eventually, after you pull data from IPFS onto your local machine, you do some analysis, and eventually you'll generate an image like this. And this is NDVI, which measures the health of vegetation, where the greener the green, the healthier the vegetation, whereas things that are more white is either water or barren land. And what really got my gears turning with this is, okay, this is great. We're using IPFS. We're using a decentralized storage protocol. And we can also put this result back on IPFS, which makes it verifiable, but it's still not very scalable, not very decentralized. So, let's see. Yeah, so what I've done is I took kind of these workflows, we've turned them into Docker containers. Those Docker containers can run on a local machine. That's taking care of the environment, not taking care of the fact that we're still using the local storage, still using the local compute. These Docker containers could be sent to Bacalhau for doing kind of a decentralized compute, and that we don't know what node they're going to, and it's now disconnected from my local hardware. But it's still not quite compute over data because these Bacalhau nodes clearly don't have the data that they're going to be analyzing, so there needs to be data still pulled from IPFS. But what we want to get to is the idea that we're working on the same data, we're using the same algorithms to process that data, and then we want to make sure we're getting the same result. So if we put this in perspective of researchers, if we're doing a paper and someone wants to replicate or reproduce our analysis, we want to make sure that they can easily get to the same result we did. And if they're using their own data, they know they're getting the same, they're using the same algorithms. And this really brings us to kind of this final step of we're exploring the idea of a data DAO, or collaborating with other universities. At University of Maryland, we have quite a lot of storage, quite a lot of compute on premises, and there could be a world where we store lots of Landsat data, maybe we store other useful data sets, and by exploring things like insulated jobs that we've heard about earlier, other trusted peers, like other universities, could send compute jobs to our university to do compute on the data that's already where we're at. We could also go into collaborative Filecoin deals with other universities that want to work on the same data sets as we do. We could even explore allowing trustless actors access to our compute infrastructure. Perhaps a token-based system could facilitate that. But really, I'd be excited to meet anyone here that might work for a university or any institution that would be interested in a collaborative data DAO. And if you want to learn more about our project, you can go to easierdata.org. You can find me at _jsolly, also on Blue Sky. I'm there as well. And one last plug we have a decentralized geospatial web working group, which is we've had really great attendance in our last one of about, I think there was like 30 or 40 people that showed up. And the next meeting is on May 17th. We're going to be getting a representative from the Foam project, and they do immutable and verifiable location proofs. And this is just a great working group of people that work on geospatial data, that are really interested in Web3 and blockchain and just using these decentralized technologies for geospatial workflows. Thank you. And I believe I have some time for questions if anyone has any questions.
So one thing we hear a lot
Oh, and the mic's coming.
One thing we hear a lot of is a desire for data catalogs, either kind of private data catalogs or maybe ones that are published. I was wondering if you had heard of, particularly either for yourself, like for things that UMD creates and produces, or potentially, even before you get to a university DAO, a data catalog that potentially has rich metadata and schemas that span multiple universities or multiple data sources, if you have any thoughts on that.
Yeah, and this will be really interesting in that, like the JEDI program that I mentioned earlier is a project that's funded through University of Maryland, and it's actually on the International Space Station and goes around the Earth. So currently, there is a few different places to get, when I'm mentioning geospatial data, there's data.gov is a catalog of geospatial data, but what David's really getting at is there is an issue of data silos where many universities and institutions are just storing their data and not making it available. So I'm quite interested in this idea of curated data sets, especially ones that are using decentralized technologies like IPFS. I think there's practically none. Everything is just FTP links, HTTP, things that can go down. And this is really kind of a problem in terms of censorship resistance of these data sets can go down, they can be censored, but it'd be great to actually have a curated data set, have the metadata, have everything we want on technologies like available over IPFS would be a great thing. Anything else? In the back? Oh, sure. Let's see. If you go to our website, easierdata.org, and you click on this, it's DGWWG. And you can see this was our last working group was with John Hoops, who does work on Astral, which is representing geospatial data on chain. And we have a recording for that down here. You can watch the whole recording for John Hoops' talk. And then the one for this upcoming one is with Ryan King from the Foam project. Thank you so much.